Welcome to Mydbops Open Source Database Meetup 12th edition. To subscribe our channel, click on the bell button, like.
Hello everyone. Myself Darshan Jayarama, and I am a technical services engineer here at MongoDB. Not here, it's somewhere far. So I am working with MongoDB since past 3.5 years, and I came to Mydbops meetups couple of times back, and this is the first time I'm presenting here. And thanks for the opportunity, and thanks all for coming here all the way, to here. And without further delay, let's get started into the time series. Okay. So this will be the agenda of the day. So in this, we can come to know like what is the time series data, right? And then what is the time series collection in MongoDB 5.0. Okay, and then we'll quickly get into the demo, and in the demo, like we can, see how in real time the MongoDB time series data will be helpful for your time series collections. And then we also released MongoDB 6.0 and with the betterment for the time series collection in the 6.0. And I'll also coming with the limitations that what and all limitations that we have in the currently, and what improved in the 6.0, and then that will be we'll become to know like what are the limitations and everything. So if anybody is aware that what is the time series data, so according to the Wikipedia, right, like this is data that is with a timestamp and for the one particular symbol or one particular meta ID, right? So anybody have any explanations, or anybody can give a thought for that? Like what is the in usual day, like where all you can see the time series data? Come again? Uh-huh. Yeah. So Grafana is obviously like it will be take the data, and then it will be according to that it will take a graph. Yeah, that's correct. Any? Come again? Okay. Cap services. Can you bit elaborate? You mean like how, like any? Yeah, that's correct. Like these kind of caps will be keep on sending the data to the users, like where exactly the cab location at the moment, and based on that, like they will be also have a sensor to track what speed that the particular car is at moving, and maybe in some advanced level they will be also having something like a fuel consumptions, and how far the current fuel can last for. So like that. So this will be the sensors data. So usually that's what we call the IoT, Internet of Services, Internet of Things. Like every sensors will be sending the data. So here you can see time will be the time of the current time, right? And meta ID will be maybe the car number or the sensor that is there in the car. Like if you take an example, of a mall. Okay, so this time series data will be so evolved, like how it means go enter into any mall, and let's say 100 people enter into the mall, and they will take the escalator, and let's say 80% of the people or 80 people takes the left turn and goes to the left side of the shops, and 20 people maybe takes the right side of the turn. So these sensors will be reading how many people are this side of the mall or this side of the shops, and that gradually increases the AC temperature, or the maintain the AC temperature for this, and reduces here, so that it can avoid the power consumption, like it can reduce the power consumption, and that can and even also for analyzing the data, the right side of the shops can be pick for the higher rents, and whereas the left side of the shops can be given as a lower rent, so like that. So based on that, the data analytics will be useful for this kind of time series of the data. Okay, so this is a sample, stock market data. So stock market is also like every second you can see, every second the stock's price will be varies, like 5 paisa, 10 paisa in the New York Stock Exchange or the Bombay Stock Exchange. You can see the every seconds you can see the stock price will be varying, right? So in the here you can see symbol will be constant, like for a given stock price, the symbol of that particular stock will be constant. That means like only for that stock, according to the time, the current price will be keep on changing. So that's how it can using that, like you can do the analytics of your own, and you can pick that particular stocks, comparing to the history, and again like based on the further calculations. Yes, next. Okay. So why do we need a time series collection? So I give a brief intro about the time series, right? Like what is the need of the time series collection? Anybody has any thoughts? Why do we need a special treat for the time series collection? It can be it's just another data, just another JSON document where it is having a, instead of string, we have a time stamp. That's it. But we also have a timestamp in other columns also. Any okay, cool. So when you say analytics, like why do you think it need a special treatment? Yeah. Yeah. So when we say time series, it may be a simple data, but the time is gradually increasing, right? Like it's not reducing. When you say something like any other data where the time will be varying, like they may be taking the history of the previous time or the current time, or the there will be a there will be not frequently coming with the same particular meta ID, right? So using that, what will happen, the normal collections, not only in the MongoDB but in all our databases, in the normal collections, this handling of this time series data in the when it grew larger, so that will be very difficult, and that's the reason we need to have the time series special collections. Like even when we got and started getting the feedback from the community users or the MongoDB users since beginning, like because MongoDB is specially designed for the unorganized or the semi-structured data. Like I cannot say completely non-schema, but there will be some particular structured data. And when it comes to the time series, most of the data will be, it will be huge. Whereas in a normal particular collection, we will be having a page size, and this time series data will be too less for this particular page and block size, right? So that's the reason it needed a special treatment. Okay. So that is the with that particular inputs from the users, from the whoever is building their application, we come up with a time series collection that we introduced in the MongoDB 5.0. So if you want to get this feature, you should be in the 5.0 and above. So this is a common differences that we can observe in the regular and time series collections. Like in the regular collection, you will be having optimized for the random reads and writes, and that will be only for that particular pattern, right? Like it will be appending, the new times will be coming and it will be appending on based on that. Okay. So here it will be like there will be no bucket concept, but here we will be having a bucket. In the coming slides, you will be understand this very well because I have a very good GIF So with that, like, you can easily understand that. Okay. And when we do the range scan, right? So if there is no indexes, or if there is a particular for one particular symbol, if you want to do the range scan, it has to do all the data. It has to do all the data in that particular page and read that and load it to the particular memory, and only read that line of the document for that particular symbol, and then throw away all other data in that particular page. So that's when it comes to the large amount of data, this will be very tedious task for the database engine to handle, and that's where the time series collection takes an advantage here. Okay, so this is the how you can create a time series collection in the MongoDB. It's just like till here, if you give it out create collection and then the collection name, it will be created as a normal regular collection. Whereas time series will be having another document where you will be mentioning the time series document. Inside that, you will be giving the time field, which will be having the particular timestamp value, where it will be having the particular timestamp, and then meta field will be the field that will be uniquely identified from which device or from which particular symbol that you are getting the data. Okay, so when I told stock market data, in that you could have seen the symbol was Asian Paint, and that was keep on changing according to the time, right? And then the granularity, it will only this one is the mandatory thing. These two are non-mandatory, but granularity will give you like how frequently your data is coming to the database. So here we have three value. One is the seconds, and then the minutes, and then the hours. So hours is the maximum granularity that you can specify in time series. This will be seconds. There is no other default value for these two, but for the granularity, it will be seconds. Time field? No, you have to specify. Time is the mandatory. Time field is a mandatory. There, you will be specifying in your collection which column is having the timestamp value. Okay, so based on that, like, it will be create a next level. So how time series collection is created is, when you create a time series collection, it will create as an immutable views. Okay, so it is just a view for you. Under the hood, it will create a view collection. From that, it will create a view, so that it will create a different buckets for the different symbols or the meta field that you have specified. Okay, so press one more time. Yeah, so here you can see, so this is the regular collection. Okay, so as you can see in the red color, you can see the device 0 is for this particular timestamp is sending some particular value, right? So and in the gray, it is having it is sending by the device 1. Okay, and here also you can see like different color is from the different devices, where in the regular collection it will be having one page. Okay, so each page will be having the data, and it will be filled up as it comes into the database engine. Okay, and when you want to read this particular value, like maybe device ID is 0. Okay, so you want to analyze this particular device analytics. In that case, it has to load all the pages to the memory and read only those selected data, right? And while loading to the memory, all those data, whatever present in that particular page, is unnecessary. Even though you have created an index, it needs to load those pages, even though it will be having a small amount of data. And when it comes to the time series collection, each device will be having its own page. Okay, so as you can see, red will be only stored in this particular page, whereas blue is from the device ID 4, how much the data comes in, right? So it will be storing along that particular page. And in this case, what will happen, even though you do not have the index, okay, on that particular column, especially for the device ID is the meta field, and from is the timestamp. And when you want to read, especially like a device 0, it no need to read any of other pages. It just need to read these particular pages, page load from the storage to the memory, and then do your filtering or any further processing in the queries. I hope that is clear, right? Um, yeah, like the regular index can be created. Okay, that's what we call the secondary indexes supports, that is starting from the 6.0 and above. But the whatever the command that we are using, right, it will be the same. There will be no changes in that. Which one? From? This one. Okay. Yeah. So this is that even like this is the index that we created. Even though if we do not have the index, that's what I specified. Even though if we do not have the index also, we don't need to scan entire collection. Okay, whereas in this case, if you do not have the index and if you specify some particular query, okay, in that case, like it has to scan entire document in your collection. Whereas in this, only those particular, whatever the amount of data is there in this particular page, even in that particular block, I mean, sorry. Okay, so in that particular block, how much pages are there? So it will be need to read all the block pages, and with that, like you will be getting the further answer for that. Clear? Okay. Any doubts? Yeah, sure. No. Actually, such that like you mean to this meta, right? How many number of meta that can be? No. There is no such restriction on that. But like obviously, because this collection was specifically designed for the IoT data, right? Like you can have as many different devices, and so that like you will be helpful for the further analytics or something. So there is no such limit. It's all completely depending on the storage. Okay. So again, like this is how the as I told, right, like previously I told the time series collection that you creating is created as the immutable view. Okay, in the back end it will create one more collection, that is the buckets. In that buckets it will be having your further data, like from this time to this timestamp, you will be having this object ID of that particular meta field, so that like it's something like only when you give a time range. So between this time range means like it will be having this information, and like each document will be having its own different meta of that particular symbol. So you will be having you don't need to read further pages or further additional blocks from the storage in order to process your queries. The underscore ID of obviously like just like a clustered index, like in the normal regular MongoDB collection, underscore ID will be created by default, and that will be the timestamp that for the how we created the granularity. Based on that, like it will be having individual each timestamp or the meta field will be having that particular information. Okay, so we can get into the demo. In the demo, like I will be downloading some stock exchange data. The Kaggle is one of the website where we can download free data, and we can load it in the regular collection, and then the time series collection also will create on along, and we can run some queries and make some sense of the queries. So that you will be understanding like how these queries will be useful. So this is a website like the Kaggle, like you might have known, like this is a very commonly used for data that you can get it. So here is a download button. If you click that, like you will be getting the particular downloaded value, like it will be CSV format. So each particular stocks data will be there as the downloaded each particular stocks will be having the data since from 2000 to the current date. So based on that, like you can, and I have clubbed all of them and made one particular file that is in 50. Yeah, so I just cat each file and then put in one particular CSV file. Okay. So here in this you can see that the timestamp is not in the timestamp format but in the string format of the just a date related thing. So for that, like we can get in here. So my current MongoDB version is 5.0.9. Okay, so it may not be the latest one, but everybody can hear, right? Yeah, sure. So in order to import this file, like I'll just grab my file. I'm not sure whether my MongoDB is running or not. Okay, so I don't have MongoDB running, so I'll just quickly launch one replica set of single node. Because we being in a MongoDB, we don't recommend standalone database, so we always recommend single node replica set. But here it is not the mandatory thing to have a replica set only in your in order to make utilize of this time series data. Okay. So mlaunch is an mtools that is open source that you can use to launch the test instances. Yeah, so my MongoDB is created. As you can see, it's 5.0.9 and we don't have any database here. Yeah. It stops shared actually. Should I share again? Okay. So ShowDB gives me, like we can see, like there are no particular database here. So in order to import that, like I have my file here. Okay, so you can see that the data is in the date format. Okay, it's not in the date format, but it is as a particular string thing. Okay, so now we can import this data using the Mongo import, and then we have to give a type as CSV, and then we will be having a header file. Okay, header file means the first line of the particular CSV file is considered as the column name while importing the data, and then we can give the DB name as -d, maybe like TSDB. Okay, and -c will be like, this is not the time series collection. I'll be importing to the like normal collection, right? So I will be importing as Nifty 50, and I will be giving my file name. So it will import the data. As you can see, it is importing to this particular field. Okay, So now I'll get into the Mongo of TSTB, show collections. Right, so I have my particular collection here. Okay, so Nifty 50 and db dot nifty 50 dot find one gives me a sample of this particular, how the collection is created, and those values, imported as in this format. Right. So as you can see, the date is a string format. It is not still in the date format. So for that, we'll export this data to another collection, but that will be again a normal collection. We don't want that to time series collection. We can create the time series collection in the next time. In further minutes. Okay. So db dot nifty 50 dot aggregate. So I'm just aggregating the. I don't want underscore ID. Okay. So then I'll be aggregating the value, and in that, I will be projecting. Project means it is to in order to project the value in maybe only those fields that you are interested. You can use different functions in order to change the type format also. I mean the data type format. These brackets are, you have to be very careful. And here I'll be projecting date to the date format, and that will be my $date. That means each values in this particular date field will be converted to true date, and then it will be sending, we will be outputting this particular data to the different collection. So just copy all other things. So I want all other fields to be specified except the underscore ID. Sorry for the long commands, but I just want to make sure you guys love the aggregation. So with this, I am I am just this is how it will be printed. As you can see, the date is converted to the ISO date format. With that, we can export this data to new collection, maybe N50 collection. Okay, so this is a normal collection. I'm just closing the particular tab, and yeah. So with this, it will export all this data to the Nifty 50 collections. Okay, and yeah. So with that, we will be having two different collections now. Sorry, show tables. Okay, so Nifty 50 and the N50 collection. So we don't want this Nifty 50 now, so I'll be just dropping this collection. Make sure if you are not using the collection, better drop it. It avoids your spaces, even the indexes thing. Okay, so you can see only one particular column we have. So now let's create a time series collection. Okay, so db dot create collection, and in that I'll be mentioning N50 ts. Okay, so here my time series collection will be having the time field as the date, right? So yeah, so my time series will be having this particular. This is the time field, and then we will be having the meta field. Meta field, anybody can guess what will be the meta field? Here is the sample data. Yes, symbol will be the symbol will be the, and granularity will be the highest one that we can have. Here it is in the days, but we granularity. I'm very bad at spelling. Okay, hours. So the highest granularity that we can give as the days is not there. Okay. So with that, like we can have our time series collection created, and if we do the show tables, right? Show collection, it should be. I am from the MySQL background, so I use. Yeah. So show collections, you can see gives you this is the collection that we created N50TS, and this is the view. As I told, N50 is created as the immutable view, and this will be the actual collection. So wherever it will be having those information. Okay. And now what we'll do is we'll import the data of N50 collection to this particular collection, the time series collection. So it's one thing is like we cannot use the $out in the time series collection. You cannot use the aggregation, but we have a hack like N50TS and then insert many. So insert many takes an array of the document and it will load it to itself. So inside this will be like db.n50 call, okay, dot find, and we'll make it to 2 array. So all the output in this particular N50 collections, right, that will be put kept under the array document, and whatever the array document is created, that will be inserted in the N50TS collection. That means our time series collection. So this is inserted. It will take time because it has nearly like 200,000 records. So nearly like it gave back how much object ID is created. So let's do like N50TS dot count document. There is a bug in the db.collection.count, like where it will be having in a sharded cluster. If you run the db.collection.count, you will be not having the particular exact document. So we always recommend to use the count documents. Even though count and count document gives the same output. Okay, 1050 years. By default, okay. So collection.count, and if we do the same for TS. Okay, so you can see like we just without anything, like we just inserted the record to the without any changes. So both collections will be having the same data, right? So what we'll do, we'll just grep the log file, right? So when we grep the log file, we'll be understanding how it was here. Yeah. So I'll do the tail -f of this one and just grep. Okay, this is not shared. It's not shared in the Zoom, right? How can I share that? That screen is not coming here. Okay. No. Entire screen is not coming. Okay, let me share this one. Yeah. So I'll be grepping my that database only. Like I created in the TSDB, right? Yeah. So TSDB I'll be grepping. Okay. So now I'll just I'll just reduce the profiling level to 0, so that any query that we run will be captured in the log file. Okay, db.set profiling level to 0, 0. I don't want to enable the profiler. I just setting the slow ms to 0. That's it. Okay. So with that, it's captured here. Okay. So now let's do some query in our in our particular uh, normal collection, that will be db.n50 collection dot aggregate. Okay. So inside that, like I'll be giving as of now, you might have seen like we did not create any index. So there are only the underscore id index, that is a clustered index in the collection. There are no any other further index in either of the collections, right? So if we do that, like I'll be just uh, matching the symbol. Okay, sorry. So I want to filter out only those symbol with maybe I want to analyze maybe like Asian Paints, stock details. Okay, and I will be giving closing this one. Yeah, and then I will be grouping based on the how many days, like how many like each month how much of the high value and the low value of that particular share. Okay, so for that I need to project. So in the project, like it will be projecting the date field as so it will be like each date will be projected as different parts, like different part of that, like year, month, like that. Yeah. So with that, like then we will be projecting the symbol as well, because if you do not mention the symbol, it will be not printed high value and the low value. And then I'll be grouping this value. So my underscore id will be, I'm just taking a note from my uh, you know, the pre-written script, because I don't want to think and type it. So symbol, and then I will be grouping based on the yeah. So this is a final aggregation query that yeah. So each value. So let's remove this two array part. Okay, so this is how the sample output will be. You can see here. So this is how the sample output will be. Like the for the January month of the 2000, you can see the high of this share value was 530 and the low of the particular share was 370. Same way, like this is how the sample output that will be given by this query. You have noticed that the query written very fast, right? Like the N50 collection is not a time series collection, whereas this is a time series collection. The query will be the same, just I'm changing the collection name, and you can see like this is also written the same way, right? So this is a sample log entry for that particular query that we have performed. Okay, so this is the log entry for that particular command that this command, sorry, this entry for the N50 collections, right? So here you can notice that this is a collection scan, right? There are no plan summary, there are no entry for the index. Obviously, like as we do not have the index on any of this match filter, obviously it has to perform the collection scan, right? And you can see the document examined is nearly like a 235,000 documents. That is almost each and every document was scanned, and it took nearly like a 153 milliseconds. And this is the entry for the time series collections, right? You can see here NS, yeah, NS and aggregate on the N50TS. That is the time series collection that we have created. So you can see like this is also performed collection scan, whereas the document scan for the same is 16,000. Okay, and it executed within the 36 milliseconds, where this took nearly like a 153 seconds, right? So even though we do not have any indexes on this one, because this is also performed obviously collection scan, you can see, yeah, so it is also performed a collection scan. It no need to read the entire documents in your particular collection, because that is the main reason is because of the bucket style storing of the particular value. Okay, so yeah, so that's yeah, so that is some of the demo that I had for you guys. Any doubts, you can feel free to ask me. Yes, please, next. So this is the same thing I have explained, right, in the particular demo session. As you can see, this is, even though we're running in the time series collection, here under the hood, like it will be fetching the data from the N50 buckets, because each symbol will be created as a buckets, and in that buckets it will be fetching the data. That's why it don't need to read all of the document of even though it's performing the collection scan, it don't need to read entire document or the entire collections of how many documents present in that particular collection. It need to read only the documents present in that particular bucket of the given collection, whereas in the regular collection it has to perform all the documents to be loaded to the memory, and then maybe if you notice this storage section, right, it is again a document. In the document, like it will be having how much data it read and how much time it took in the microseconds, how much time it took to the reading the data from storage to memory. As the storage is very less, I mean the collection size is very less, it is not showing. Else it would have been like in the big collection, if you have you can notice that thing, and further things, everything will be the same, right? Like the result length, if we notice, obviously like we did it returned the cursor ID, means like there are still more data in the cursor. You have to do the iteration in order to get that particular data, but result length, you can see here it is 9308. It will be also would be the same, almost same, 9306 maybe, because of the collection length is bit less, right? That length, because of that particular length, it is showing bit 2 bytes of differences, but it will be the same result length in the both particular collections. Next, any doubts? Compression algorithm in the sense like yeah, that will be different compared to the regular. You still have an options to change that. Yes, storage size will be same, but like when you allocate a bucket, or when you allocate a bucket, so that will be having the default page size. Okay, so the page size maybe for one particular bucket, it might not have that much data. Okay, whereas in the normal regular collection for that bucket, even though different symbol data will come, that can grow, right, but it will be occupied there. Like you have 10 buckets, and each bucket having single data, you will be having maybe page size of 4 kb, so you'll be having a 40 kb of collection size. Whereas in the normal collections, in the regular collection, you will be having maybe like one document of somewhere around like 100 kb or something, and same 10 documents it will be there. So it will be it can't be like 100 kb, like less than like maybe like 1 kb you can think, and you will be having a 10 documents, it will be 10 kb, right? So maybe like 12 kb. So in the regular collection it will be 12 kb, whereas here it is the 40 kb because of the page size, because it has to reserve that particular.
Optimize that storage level, right?
No, you cannot say that, because like this is just an example that I have given. Okay, because it has to reserve the space for that symbol. Like when the next time the data coming from that particular symbol, it has to store inside that particular field only. So in order to that, like it has to reserve that page for this particular symbol only.
Okay, so it cannot be predictable. It is like
like 1 or 2 pages will be differences will be there. 1 or 2 pages differences will be there. Like once it is that page is full, then the new pages will be recruited to store the data. Clear? Yes. That's the meta field that you will be mentioning, right? While creating the collection, you will be giving the meta field. So meta field, like take an example for Ola. So each car will be having a sensor. The sensor will be having a sensor ID, right? So that sensor ID will be having one particular bucket. Okay. Yeah, so we recently released MongoDB 6.0 in the MongoDB world. That happened in the month of June, July. Yeah, but we reverted back and then did some again modification, and recently we again released with like a last week, in the last week or something. Okay, so with that, like we have introduced the secondary indexes on the collection. So now with the MongoDB 6.0, the secondary indexes or the compound indexes of any particular field that can be created in MongoDB 6.0, and we have improved the read performance. That is again based on the particular benchmarking things, and a lot of further improvements that performed especially for the sort operation when it comes to the sorting, because by default it will be sorted based on the meta field, right? Because each meta will be having different buckets. So as you load into your memory, it will be loading based on that particular sort order only. Okay, so that was a big performance issue in the 5.0, whereas with the 6.0 it was released. And in the future also you can expect like cluster to cluster replication thing, and scalability in terms of considering the time series collections. Any doubts? Okay, so what are the limitations in time series is like we have a documentation section in the our docs.mongodb.com. In that, like you will be having all this particular information here. One thing I have explained is the dollar out in the where we did for the normal collection, the N50 collection that we exported as $out, right? That you cannot perform in the for this time series collection, and there are document limitations for 4 MB, so that is the limitations. And then you cannot convert the time series collection to the regular, like you have to drop, or you have to Mongo export, or any other method like Mongo dump, and then you can use it. And currently the transactions are not supported. Maybe in the future versions, like that is again that will be next tasks. So that's all my time. So I'm open to questions if you have. Uh, the direct answer is no, but obviously we do not recommend that because the T.X is having the internal metadata collections will be different than the 6.0. So it is always best practices. Even the authentication things like in the 3.0 we have a MongoDB challenge response, whereas in the 4.0 we removed that, and many things are there. So it is not recommended way like to upgrade. Yeah, yeah. So let's limit these topics to the time series. Yeah.